everybody, welcome to example A, and it says write the equation for this parabola in vertex form, factored form, and general form. So just remember vertex form. Vertex form is if we know the vertex, that's going to be A parentheses x minus h squared plus k, where hk is the vertex. Okay, factored form. And that's going to be where the roots are, the zeros are, the x-intercepts. We're going to say x minus r1, parentheses, and the a has to go in front, x minus r2. Okay, where r1, comma 0, r2, comma 0 are the roots. Alright, and general form is just ax squared plus bx plus c. Okay, and if it's an equation, I guess I should probably have it be y equals, but we'll do that here in just a second. Okay, so what we're going to do here is let's look at this one. We have -5 and 3, so I see these right here. Let's just use a different color here. Right here, this one and this one are my roots. So those are the things I'm going to use for factored form. So if I want to do factored form, because it says all of them, factored form, I'm going to write y equals, I don't know what that a is yet, so I'm just going to leave it as a, and it's going to be x minus, and the first one is -5, and the second one is x minus, I think that's a 3, I'm pretty sure that one's a 3, it is. Okay, and then it's going to be x minus 3. Now what I would suggest you do is write the minus in every time, so that way you don't mess up, is it plus or is it minus, and then you can always fix it later. If I want to just change this to plus a positive, I can do that and then just make it look a little bit better. So I would suggest doing that. Okay, so the next thing is let's write it in vertex form. Vertex form is going to be y equals a, parentheses, and it's going to be x minus -1 squared plus my k value is -8. Okay, so I'm going to change this again to plus a positive. I like to write it in just so I don't get the negatives messed up. So we have this thing as my vertex form, and then general form we can go in and use vertex form or factored form to get there. Okay, we're not going to do that just yet, because what I want to do is I want to figure out what this a value is. Now what's nice is that this a value will be the same as this one. All these a's here, here, and here, they're all going to be the exact same number. So we just figured that out for one of them. So what we need to do is we need to plug in a point that's different than the points I use for either factored form or vertex form and plug it in. So if I want to plug this, if I want to use this number, I can plug it into vertex form. Or I can take one of these two and plug it into the vertex. Did I say vertex form? Plug this into factored form. Take one of these two and plug it into vertex form. Okay, and it doesn't matter which one you choose. So which one should we plug in? I'm going to plug in 3, 0 into vertex form. Alright, so what I'm going to do is let's figure out what a is. So we're going to say y. We're going to take actual x and y values this time. So my y value is 0. So I'm going to put it in here. So we're going to say, let's do this. Oh, it's going to be 0 equals. And I don't know what a is. My x this time is going to be 3. And it's going to be plus 1 squared minus 8. So all I really did from vertex form to this one is just plug in my points 3, 0, and then I should be able to solve. So I'm going to end up with 0 equals a, and 3 plus 1 is 4. 4 squared is 16 minus 8. Okay, and notice how I have multiplied first. A lot of you want to subtract here. Nope, it's 16 times a, and then subtract 8. So now what do I do to solve for a? I want to add 8. Add 8, and I get 8 equals 16a. And then divide both by 16, and I should get 8 over 16, or a equals 1/2. So that means a equals 1/2 for all of them. So I can actually go back in, and I can replace the a with 1/2. So this one is 1/2, this one is 1/2. And we'll have factored form is going to be 1/2 times that. Vertex form is 1/2 times that. So now all we have to do is get it into general form. Now it doesn't matter which one we use. I'm going to use factored form because Well, I used vertex form before. All right, x plus 5, x minus 3. I need some more space. So I've got y equals 1/2 x plus 5, x minus 3. Okay, so you can actually make the rectangular box diagram if you want. All right, and we have x plus 5 and x minus 3. Nice and straight, as you can tell. So what goes in this box? We have x squared. What goes here? 5x, negative 3x, and this is a negative times a positive, which is negative 15. So I can rewrite this part, not including the 1/2. So I can actually rewrite this as y equals 1/2. And then I'm going to put it in parentheses. So I have 1x squared. I have 5x minus 3x is plus 2x, and then minus 15. Okay, so then the last thing to do for general form, remember general form is ax squared plus bx plus c. I just need to distribute this 1/2 into all of them. And so general form should be y equals 1/2 x squared. 1/2 times 2 is going to be just 1, so I can drop the 1. And then 1/2 of 15 is 15 over 2. All right, and there's general form. So now we are all done with vertex form, factored form, and general form. Okay, good. Here's example B. A rational expression can be reduced if the common factor in both numerator and denominator. So if we have the same thing for both of them. So we're going to say reduce the expression here by factoring. Check your answer. So we have x squared plus 2x minus 24, and we have x squared plus 7x plus 6. So what we're going to do is let's use the rectangular diagram for both of them. Alright, do you have to use a rectangular diagram? No, but I think it kind of helps. At least visualize it. Alright, so let's see if we can figure this out. Well, I know I've got x squared. Has to go here. Negative 24 has to go here. Since this is a negative, one of these has to be a negative, one has to be a positive. So I'm just going to make this one a negative and make this one a positive. It doesn't matter. Now we look at the middle term and say this is a plus 2. So if I add these two things together, they have to be a positive, which means this positive term has to be further away from 0 than this negative term. Okay? So, let's see if we can just get rid of those. We don't need those right now. Alright, so I need to multiply to 24. What are some numbers that multiply to 24? Well, 6 and 4 do. And since one is positive, one is negative, can I subtract these to get to positive 2? Yeah, the 6 could be positive. So if I have this to be a 6x, and I have the other one to be a negative 4x, these two add to 2x, and that works out. So I have x plus 6 and x minus 4. So I can say this whole thing is going to be the same as x plus 6, x minus 4. Alright, good. Now let's do the same thing. I got x squared here, I get a 6 here. It's a positive 6, which means either they're both positive or they're both negative. And one way to check that is, let's now look at the middle term, the b term, and say this one's positive, so that means both of these have to be positive, because a positive times a positive is a positive, and a positive plus a positive is a positive. So what numbers multiply to 6 but add to 7? They're 1 and 6. So if I have a 1 here and a 6 here, x goes here, x goes here. Let's just check. This is 1x, and this is 6x. 6x plus 1x gives me 7x. So that means I get x plus 1, and I get x plus 6. Close my parentheses. Okay, so now what I have is this is the numerator, this is the denominator. So I'm going to rewrite this expression over here. So on that top, which is this first box, I get x plus 6 over, or x plus 6 times x minus 4. And I just wrote them separately. Alright, different colors. And then we're going to do the same thing over here. It is x plus 1. I don't use that color, sorry. We have x plus 1 times x plus 6. Okay, so is there anything that both the numerator and denominator share? Well, I try to make sure that they were in the same color. Just because they're not first doesn't mean we can't divide by them. If I'm multiplying by x plus 6 and dividing by x plus 6, that means this and this can cancel out. So this factored, this expression can be reduced after we factor it into x minus 4 over x plus 1. Alright, so that would be it. much simpler than this whole big trinomial divided by a trinomial. Alright, good luck.